Hello everyone, I am William Pittman. I am the Senior Fire and Gas Detection Consultant for MicroPack in the Americas. I'm based in the United States and I provide consultancy support for our licensees and clients in the United States, Canada, Mexico, and South America. Today we're going to be talking about the Flame Detector Optimizer tool in HazMap3D, which was introduced in version 21.05, which was released recently. The Flame Detector Optimizer tool allows you to run an automated process that will move detectors around up to a certain number of detectors, adding them to an assessment and putting them at different positions and testing the assessment results to see where we might get the best coverage for a fixed number of detectors. This is particularly interesting and useful sometimes in that I may know for a given area that I'm probably going to have a flame detector on one of these posts, but I may not know what elevation and what post specifically I want to attach the flame detector to, or what might give me the best coverage. And the Flame Detector Optimizer tool lets me rapidly go through several iterations and lets the computer tell me which one it thinks is better or better suited to the task. And I can do this either with an assessment where I already have some detectors placed or a brand new assessment with no detectors placed. Today I'm going to be testing this with a brand new assessment, no pre-existing detectors in the model. So to kick this off, I am going to say add flame assessment folder, and I'm going to call this optimizer test. I'm going to graphically draw a assessment volume with a 4-meter offset. And you want to be at least a little bit mindful of how you draw your assessment volume when you do this. Because, and I'm just going to get this 9 assessment slices, so I'll get 1 assessment slice every half meter. And my DEC-Z is going to be 100.1 meters because that's what this model is set up with the ground plane as. And I'm going to say show assessment volume, just so I can show you something real quick here. So because I have sliced my assessment volume this way, I'm cutting through the back half of these, grade bubbles. So all of the back half of these grade bubbles and these pumps back here are not included in my assessment volume, so that will not be assessed, and so the optimizer will not consider coverage back here when it's optimizing the layout. So that's something to be mindful of when you're setting this up. So with that set up, and I've already got my grade bubbles assigned, I'm going to come back in here, shut off, show assessment volume, and then I'm going to say add optimizer node, and that creates this optimizer node, which I can then double click and say I'm going to optimize flame detector coverage. That's the only option that I can have for the optimizer, especially with the flame assessment folder. I'm going to tell the computer that it can use up to 3 detectors. I'm going to specify the make and model I want it to use, and I'm going to say use the MicroPack F303 standard at 75% modeled sensitivity. I can specify a max pan or tilt, and this can be positive or negative, so I'm going to tell it that it can have 180, so it can have these facing any direction it wants. I'm giving it free range there. And I can also give it a maximum a minimum and a maximum tilt value. We define down tilt, which is what you want, as positive, so I don't want to be able to give it a negative, a negative tilt value, which is having the detector point up. So I'm going to say 15 to 25, which is going to have the tilts in the range that I want, because typically we want them to be at least within 10 to 30, so we're going to go with 15 to 25 here. And then I can tell it to, I'm going to tell it what surfaces it is allowed to mark or put the detectors on, and I can do this graphically. So I'm going to say add graphically, and I'm going to click here, and I did not quite get the surface that I wanted there. Okay, now I'm good. I'm going to extend this over, and I'm going to define this in such a way to where it can mount the detector to either of these rows of horizontal support structures. And then I'm going to hit save for now, close that, change my angle a little bit. I'm going to say add graphically. I'm going to click from about here to here to allow it to mount to this surface. And then I'm going to look over here and say add graphically and let it mount on this group of bars on this surface. And something to be mindful of, I'm telling it it can use three detectors, and I'm telling it 3 surfaces that it can add. So in this way, depending on where you're allowing it to mount, over what size of area, you can kind of rig the assessment to give you a result kind of similar to what you're expecting or what you think the setup needs. In this way, you might not get a true optimum solution. It's going to be an optimal solution for what you're telling the computer is allowed. But this is important in that I want to be able to control my elevation. I don't want detectors at ground level, so I want to control that. And also, I have an idea in my head of what I think will work. So this gives the computer some constraints and then allows it to optimize within those constraints. So I had this idea in my head, and that I think there's going to be a detector back here, I think there's going to be a detector back here, and I think there's going to be a detector over here. But then it lets the computer play around within those constraints to figure out how it can adjust things to give me the best result. And with those parameters put in, I'm pretty happy with that, and I'm just going to tell it to run the optimizer. And it's going to run through, and at first it's bouncing all over the place and iterating quickly. Now it's going to iterate a little bit more slowly. You can see it's rapidly dialed in to something similar to what I was talking about, where you've got a detector over here, a detector over here, and a detector over here, and it's just adjusting mostly pans and tilts at this point, not making any huge adjustments at this point from the looks of it. And how long the optimizer takes to run is going to vary depending on a whole bunch of things. It's going to vary with the number of detectors you told it, how much there is graded, how much it has to optimize. If you have a very good computer with a lot of processing power, you're probably going to see faster results than if you have an old computer. I'm currently running this on a 5-year-old laptop, so you might, if you're running a similar assessment to this on a newer machine, you might get faster results than this, but we can still see it's making pretty rapid progress towards a solution at this point. So we can see that we get a result after a couple of minutes here that is basically in line with what I was expecting. We've got a detector back here, a detector over here, and a detector on the side group of posts, and it's using each one of those 3 surfaces that I gave it the allowance to mount the detectors to. It is a little bit surprising to me in that personally, at first blush, I might have expected this detector to be on this group of posts over here so it could catch more of the back end of these bubbles. But it looks like what the computer is doing is it's saying that this detector is helping to provide some coverage over here for these pumps back here, that this detector is going to be missing some of, and probably also getting some good 2 out of N coverage between those 2 for these pumps, while this detector is probably going to be catching more of the back end of this bubble here, and this detector is probably going to be catching some of all of them. So now that I've run the optimizer, I'm just going to tell it to assess real quick. And I can see my levels rising up. And and I'm going to turn off my grade bubbles just to make my display look a little bit better. And I can see I've got 71% 2 out of n coverage, 4% delayed 2 out of n coverage, which is mostly back here, where I can see that in this area, this detector back here cannot quite detect fires back here with the kind of range, with the kind of sensitivity that I want, because it's too far away, so it can't detect fires that small with that level of sensitivity. I've got 19% 1 out of n coverage, and I have 6% no coverage, which is actually a very, very good result to have about 94% 1 out of n coverage with 3 detectors and over 70% 2 out of n coverage with 3 detectors. So that's the optimizer tool. If I want to, something I can do here is just look at these detectors, and then I can see this thing's basically on this post, so I'm pretty happy with that. If it was floating out in space a little bit here, where it was just between in the middle of this box, I might shift it up or down a little bit so that it's not going to be just floating off into space. This detector, again, I see is more or less on this post right here, either one of these posts. And this is something you might just want to look for, where it's like if you have a group of detectors or a group of posts that you can mount on, and you have a detector just kind of floating off into space, like if I wanted to, I might shift this detector just a little bit, and then I can see it's mounted at this position. I might change that coordinate just a hair. So now I'm more on that post. That's a slightly more accurate and honest positioning of this detector. And while I'm on the subject, this might be a good point to remind you to reset your camera home position. If you're working on an assessment tour, you can get back to a good view quicker if you want to. But having adjusted that ever so slightly, I might rerun. And of course I didn't change that much, so I'm seeing slightly lower 2 out of n coverage, but it didn't really change the results much. But that way I have the detector programmed in a location that's a little bit more favorable, a little bit more realistic, because you're not going to just put post anywhere. And so that is a brief demonstration of the Detector Optimizer tool. Hopefully you enjoyed this and found it informative. If you check out our YouTube channel for MicroPack, you can find that we have about 70 videos currently showing different aspects of the software, ranging from simple videos showing you quickly how to add detectors to more complicated assessments showing you step-to-step, start-to-finish assessments for flame detection and flammable gas detection. And hopefully you'll check those out to learn more about the software and how to do different things in HazMap3D.